Hello my dear student. See, in this section we will discuss about displacement work or PDV work. Displacement work or PDV work. Simply, what is the displacement work? Work done due to displacement of a moving boundary. That means there is a system and system is surrounded by a boundary, bounded by a boundary, and that boundary will moving, and during movement it is a displacement. Which type of a system, which type or in system, which type of a substance? Simple compressible substance. You know very well what is the simple compressible substance. That means it is free from the electrical effect, magnetic effect, gravitational effect, right? It is a simple compressible substance, right? And what is the degree of freedom of a simple compressible substance? That is 2. That means simple compressible substance of a gas, single phase and a single component, right? Simple compressible substance undergoing a quasi equilibrium process. If the displacement of a boundary, see, displacement of a boundary, if there is a system, and you assume that the system boundary will displaced, that means this is your displacement of a system boundary. During the displacement of a system boundary, in which manner? In a quasi equilibrium manner. That means the system boundary either expand or collapse in a very slow manner. During that displacement, the work will transfer is called boundary work, displacement work, or PDV work. So we can also say that during PDV work, what is the assumption? During PDV work, what is the assumption? Assumption number first is that this is your assumption. During PDV work, what is the assumption? Assumption is simple compressible substance. Simple compressible substance. Number second, undergoing a quasi static equilibrium process. Quasi static equilibrium process. That's it. There are two assumptions. While we applying a PDV work. That means this is nothing. This is your displacement of a system boundary, and within the system, which type of a substance? Simple compressible substance. And which type of process to be followed by the boundary? Quasi-static equilibrium process. If these two conditions fulfill, then what is the work transfer by the system to the surrounding, from the surrounding to the system, is known as boundary work, displacement work, or PDV work. See, there is a cylinder and this is your piston, right? And we take a gas which is simple compressible substance, right? There is a system boundary. For the equilibrium of the piston, we put a weight of a in the form of a different slice, very different slice. The motivation of the slice is that we remove one by one of a slice, then piston will slowly move. That means, what is the motivation of this weight in a different slice? Why? Because we are trying to that the process is quasi-static equilibrium process, right? Yeah, you may assume that there is a sand particles, many sand particles, and you remove the sand particle one by one. During that process, the piston will displace very slowly, right? That means consider a gas in a piston cylinder arrangement. The initial pressure is P and initial volume is V. The initial pressure of the system is P and volume V. And cross section area, take a cross section area A, piston cross section area A. If piston is allowed to move, if the piston is allowed to move during expansion of a gas, how it will expand? Due to remove one slice, then there is a little bit distance of there is little bit displacement of a piston. Again other slice is removed, there is again little bit displacement of a piston and come back again equilibrium. Again if you remove the slice of the weight, again it will move very slow manner with a displacement delta x, and again it is equilibrium. That means throughout the process from point 1 to point 2 there must be satisfied equilibrium process, and we join that process. That process is known as quasi-equilibrium process, and you know that quasi-equilibrium process is the thermodynamic process, right? So if the piston is allowed to move, if the piston is allowed to move, there is a movement of a piston. This is a movement of a piston. If you allow to move the piston due to removal of a one slice of a weight at displacement dx in a quasi-static equilibrium process, that means very slow process, then the work done during the process, what is the work done during the process? dw is equal to, what is the work done? The force, this is your force into displacement dx, right? Very important, this force is always a resistance force. Why? Because we know that the work transfer, thermodynamic work transfer is always taking place against the resisting force. So there is a resistance, due to weight of the piston, due to weight of the piston, and due to weight of the piston and weight of the load combined together, it is a resistance which is always oppose the displacement of a piston, which is always opposed. See, this is your resistance, this is your resistance. What is the resistance? Let mp is the mass of the piston and g is the resistance, displacement against resistance, right? So we know that work is the force into displacement, and in a thermodynamic work transfer, what is the force? What is the nature of the force? It is always resistance force, right? And what is the force? What is the force? If this is your pressure into area, what is the force? This is your pressure into area into dx. So this equation dw is equal to f into dx, this is for any process, mind it, this is for any process. Why? Because This is the definition of the work. This is your definition of a work. And what is the definition of a work? Force into displacement. So this is for any process. You don't confuse that this is your quasi-static process. No, this is for any process. But when you write P, the F is P into dA, this is your into dx, then this is your only valid for quasi-static process, right? And pressure P into A into dx. What is the A into dx? A into dx, this is your volume change. Area into displacement, there is a volume change. So, what is the work transfer during a displacement dx is P into dA, right? And the pressure P, always the system pressure. This is a free body diagram of a system. Free body diagram of a system. See, if this piston is in equilibrium, then this piston is equilibrium, then P into A, that means pressure and the cross-section area of the piston is exactly equal to the force, which is resistance force, in which condition? It is under equilibrium condition. Under equilibrium condition, right? If the piston will not in equilibrium, that means PA is not equal to F. That means this is if so if you write F equal to P into A only in equilibrium condition. P is your where P always absolute pressure. Absolute pressure. And you know that absolute pressure is always positive pressure. Right? Okay? And dV is the differential change in volume. Differential change in volume. And this may be positive and this may be negative, right? If there is an expansion, this is expansion, then the change in volume is positive. If this is your compression, the change in volume is negative. But pressure always positive. Why? Because it is absolute pressure, right? So then total boundary work done during the entire process, that means take 1 to 2, known as WB is the boundary work, which is nothing, it is integration dW from 1 point to 2 is equal to integration 1 to 2 dP. It is in so if you find what is the value of a boundary work, you always search about what, because P is the volume, P is the function of V, it is not independent. Why? Because P is not constant. Here P is not constant. P not constant. Instead P is the function of volume. If you have a relation of P in the function of V, then you can integrate this equation. That means this integration can be achieved, can be evaluated only if P is the function of, and this is applicable for reversible process. Reversible process. Why? Because there is a very slow quasi-static equilibrium process. So, if there is a system at point 1 of a pressure P1 and volume V1, and it reaches at a state point 2, system at a state point 2 where pressure P2 and V2, then this system, due to expansion or a compression of a work boundary, is known as boundary work. And what is that? Integration 1 to 2 PdV. Right? Thank you. Thank you very much.